Hey, what's up guys? My name is Ken Liujikis and this is the ENGR 251's Thermodynamics 1 for the video projects. So the topics that I'm going to do for this project is properties tables, and yeah, without wasting any time, let's get started. So basically, if you're just referring to the property tables throughout this course, throughout this engineering thermodynamics, and the basic concept that we have to bear in mind is basically every time when you want to find the qualities, which is the x, you just have to use these formulas, and v equals to vf plus x vfg. So x is actually represents the qualities, and vf is basically is the saturated liquids, and vfg is basically just like the saturated, the differences between saturated vapor and the saturated liquids. So the formulas for vfg is vg minus vf. So yeah, that's it. So uh, by applying these formulas, you can use it with others property as well. If you want to find the internal energies represented by U, and enthalpy is represented by H, and entropy is actually represented by X. And I guess throughout this course, I can say these formulas is very crucial throughout this course. You can I mean you are actually often to apply these formulas to deal with different kind of problems that you always encounter in the exercise and also exam as well. So yeah, so right now I'm going to show you a simple examples applying this concept. So yeah, so this is a problem. So that's a rigid tank. So every time when you see there's a rigid tank on most of the questions, you have to remember that and bear in mind that volume is always constant. So that means it's the the initial volumes and the final volumes are always constant all the time throughout this process. So yep. So the problems give us 12 liter, if because through this course we have to convert everything from liters to cubic meter. So you just times 10 power minus 3, so it converts it to 0 0.012 cubic meters. So yeah, so as I have mentioned just now, v1, the initial and finals are always equals, and you just can get 0 0.0015 meter cube kg. And yeah, for this question is quite tricky. They do not give you the specific volumes, you have to find out yourself, and you just have to 0 0.012 over 8 divided by the mass for this tank. So for these problems, there's two parts. So let's do it for the first part. The first part is you have to, so this one you have to get the values from the properties tables, and the temperature at the 320 kPa is actually 2.4 degrees Celsius. And oh, I forget about talking about this one crucial things for this one. So for these problems, it's actually you have to referring to the property tables for refrigerants 134A, which is probably mostly in the end of the property tables. And after that, once you get one, you have to find the saturated liquids, which is this one, and the other one is saturated gas. Yeah, so since V1 is between VF and VG, and that's why it's recognized as saturated mixture. So after that, yeah, so that's the answers for, so this the answers. 2.48 degrees Celsius is the answer for the part A for these problems. So after that, we are going to let's look for the part B. So the part B, you just have to use this concept again, as I have mentioned earlier, and it's quite easy. You just apply this concept, and you just have to use this concept to find the quality, which is 0.01158. And after that, you have to find the enthalpy by using the same concept again. And yeah, just have to get the values, everything's from the property table. And after that, because of the kj over kg, and the problems wants you to find the answers in the unit of kj, so you have to times h, capital H equals to m, times small letter h, so you will get the kj. And after that, since the final pressures for these problems is 600 kPa, and based on the tables we found that is 21.58 degrees Celsius. So after that, based on the proper tables, we can find the Vf and Vg simultaneously. So since V2 is 0.0015 because of the rigid tank, and everything is in constant, so it's can be recognized as the saturated mixture again. So after that, we have to reusing the same concept again, and to find the qualities, which is 0.02204. And the still more, the last one is yeah, you just have to find the enthalpy again, which is the problems asking you to find for the final one through this process. And based on the concept, we found that the final enthalpy per kg is 83.146 kj per kg. And after that, using the same concept again, and the answer is 66.17 kj. So that's it. So these solutions on the problems that actually is asking us to solve for two parts. Yeah, it's pretty much so okay, thank you guys. So see you guys next time. Take care guys. Bye guys. Peace out.